I heart robots.
Oh, well, we do too.
Exactly.
Who doesn't heart robots? So great. Yeah, there were some others. Quirt, Go Canada! Was excited about the Canada arm. What are some others? We could jump right into our rapid fire question session.
Great.
Answer some quick questions.
Yeah,
Absolutely.
Emphasis on the quick.
Yes.
Right? We'll try to get a lot in. All right. Tiffany, do you have one?
Yes, I have one. So let's say for spheres, how long did it take to actually create the robot?
actually designed that.
Yeah.
Well, as I said, this was a project that started at MIT with actually an undergraduate engineering class, and so the students worked on that extensively. That led to a number of different prototypes, and eventually those were sent up to the space station. But, you know, the reality is that it's hard to say exactly how long it takes to build something because you have to design it, test it. There are a lot of things for the space station that we're concerned about in terms of making sure things are safe.
Right, of course.
In terms of like materials and how it operates and all those kinds of things. So a fair amount of time associated with that. And then, of course, once they get on the space station, you know, just because you get there doesn't mean you're finished.
It continues,
Yeah. In fact, for
That's where the real research happens.
every single robot that goes up into space, we're still learning how to improve and make them better. So.
Sweet.
That's cool.
All right. A comment about Int Ball from Airplane Man 1997. So cute.
I agree. We all agreed, right?
Yes. The JP guy has a question about learning and training to do things like you guys do. Is it possible to learn robotics by self-study and tinkering with machines? What books or resources would you suggest?
Yes, I would say so. Robotics it's a very broad field, so you can contribute to a robotics project, you know, with any kind of background almost. You know, product designers, you know, programmers, electrical engineers, mechanical engineers. So really, it's whatever you love to do. You know, what do you prefer to do, and then you know, you can contribute then to a robotics team.
That's awesome. That's good news. You could do a lot of different things.
Yeah, and I think a great thing today, which didn't exist a few years ago, is there are a lot of online classes you can take in robotics. And so I think learning by yourself is totally possible. There are even open source robotics projects that you can contribute to. And so I think the important thing is just to get involved and not worry about whether or not this is in a university or at home. I mean,
you
all
can
of those
build your
things,
own robots at home, get a little Raspberry Pi and Lego set and
Get started, yeah.
Nice. Some more. Twitch Prime Quirt, you're back. I saw the floating square robot assistant Asterbee, or maybe it was the other one. I forgot the name. The assistant robots testing on the International Space Station.
You're jumping ahead.
Stay tuned. Stay tuned. Wanted to get that in there since you anticipated another robot.
And of course, we have the Space TV Net says, on the ISS, do they have something they can talk to or ask questions like Alexa or Google Home? And of course, that was Simon.
That's the idea behind Simon.
Yeah,
Right? Exactly.
Yeah,
you guys.
So yeah, those things are needed there too.
Here's a good question. Godzillers asks, can we expect robots to take over the role of astronauts on spacewalks and conduct things such as maintenance?
Well, I think, you know, maintenance is one of those things that we really want to see robots, take on an increasing role because so much of the time of astronauts today is spent doing preventive and corrective maintenance on board the space station.
Right.
And so we'd love to have robots be able to take spacewalks. But, you know, right now we have these large arms that are actually used to do some amount of maintenance external to the space station without astronauts.
Awesome.
That makes sense, yeah.
Do you have another one you want to hit?
Let's see here.
There's a question about robotics competitions.
Yeah.
Oh, yes.
Off to Mars.
Which have been on spheres
That's
for
the question.
many
That's the
years.
question. Yes,
Exactly.
yes.
It's called Zero Robotics.
All right. That's
It's
the
run
question.
by MIT, who developed the spheres. Exactly.
Cool.
And it's a middle school and high school software
way.
competition. So
awesome.
the preliminaries are done in simulation. You program the spheres to perform certain tasks. So the preliminary rounds are done in the simulation, and then the finalists get to fly their code on the spheres on the International Space Station.
Oh, wow. For real?
Yes.
Excellent.
Yeah.
Middle and high school.
Middle and high school.
So cool.
Yeah. To get started early.
Yeah.
Yeah.
I was not sending code to the space station when I was in middle school.
No, I wasn't either.
Well, I don't want to say my age, but there
Right.
wasn't a space station.
That might have been part of the problem.
That was part of the problem for me. Yes, exactly.
Right.
Well, here's another question here. For Kali Kama, do you see a point where robotics will be able to perform enough tasks where humans won't be needed on the ISS?
I'm often asked that question about the relative strengths and weaknesses of humans and robots, and I think that we will always have humans involved in space. I mean, partially it's because we as humans want to also explore. But it's also the case too that we can't do everything by ourselves, and just like any team, there's more than one person involved, and I think there'll be more than one human and one robot, and more than just robots. Really, I think the future is humans and robots together.
Yeah.
Yeah.
Awesome.
Yeah.
Cool. How about one more question from the chat before we move on, which I have now lost. Space TV Net, hello, wants to know what animal shape is the best for robots in zero gravity? Is there an animal nature inspiration for the shapes that work? There seem to be a lot of spheres. Is there a reason for that?
Yeah, well, but I think part of that is, we like, at least for flying robots, to have some sort of symmetry to them because you can fly in any direction in space. Sometimes I think robot design draws inspiration from animals. Biology has obviously evolved all kinds of different shapes, different forms, and we like to try to take advantage of that.
Yeah.
But we also sometimes draw inspiration, as we said, from like science fiction. The idea that people come up with in Hollywood for robots. I mean, sometimes it's like, hey, we should use that.
Work.
That could work.
Yeah.
Well, and a lot of times shape also, it depends on what functionality you're looking for.
Yeah,
so you build it so that it's most efficient at the job that you want to accomplish. So
that's what drives it.
That drives the shape.
Definitely.
All right. Yeah, that makes sense. Well, speaking of science fiction, okay, my question for you is, we see robots all over in movies and TV shows, comics, everything. What are your favorites?
Oh, that's easy. I mean, for me, my favorite robot is K9, which comes from Doctor Who. K9 was the Doctor's robot dog, and it had basically, a supercomputer built inside and a little laser in its nose. But K9, no question.
Have you built a dog robot yet?
I have not, but if somebody had one,
Well, I have to say that one of our previous robots in our group was named K9.
Oh, it was? Okay, after the Doctor Who robot?
Yes.
Nice. Excellent.
Nice.
Yeah, and I have to say, I don't really play favorites. I don't really have a favorite robot. I'm sorry. My favorites are real robots. So I have some favorites among them.
I mean, someone like you in your position, that's fair, I think. All right. Well, speaking of your favorites, well, no, let's come to that in just a moment.
Okay.
So we wanted to talk about characteristics.
Yeah, like what kind of qualities do you look for in a robot?
Yeah.
Right?
We look for robots that can really help out, especially when we're talking about humans and robots in space.
Together,
to really work well together. And I think just like here on Earth, there's no single definition of what a team is. The same is true in space. I mean, in fact, we could have robots that work, say, before humans, or robots that work after humans, or maybe even in parallel, or in support. So the idea is that you could have a team in all kinds of, different settings. And so sometimes we build robots to do things that might take a long period of time, and you have them work either before or after. Other times we want robots that can interact more sort of like human pacing. So just like we're talking, we'd like robots that can react to us, too.
Oh, yeah.
Right.
Do you remember the other day Terry told us his comparison to
like raising a kid?
Yeah. I should say that, and Maria and I, we spend, all of our time here at work, thinking about and trying to build robots.
Right.
Sometimes I'll admit it's frustrating because it's not unlike, trying to raise kids. You want them to grow up to be, good autonomous team members and to work with you.
Right.
Sometimes I'm not sure if it's more or less challenging than trying to build robots to do the same thing. I will say that my kids have grown up to be, far more autonomous and independent than my robots. So that's a little bit of a disappointment because I want my robots to do as well.
Just as well.
Yeah. But one of these days.
There are certainly times when you say, why did it do that?
speaking, as a father, I would say, yeah. Sometimes I look at my kids like, why did they? But anyway,
why did they do that? Why did my robot behave that way?
Yeah.
Why did my robot vacuum cleaner choose to get wedged under the couch?
What was it thinking?
I love
The
that.
day in the life of building robots.
Minds of their own. Well, should we talk about one of your
My favorite
real
robot?
life
Let's talk about Maria's
robots?
Let's talk
favorite
about my
robot.
favorite robot,
Yeah.
which is Astroby. Terry's got,
Astroby.
like,
So for you
and we just
Astroby
happen to
fans,
have one right
Yeah,
here.
oh,
This
look
is
at
the
that.
model.
That's right. This is what we call this our stunt double.
the stunt double for
Stunt double
Astroby. on
Astroby.
station.
What's the name of the stunt
Okay,
double?
so in general, these robots are called Astroby or Astrobys, but they each have their own name and a color.
Yes.
So this stunt double model you see is, here, let me turn it so you can see the color better, is orange and is called Killer Bee.
Killer Bee.
But we also have 3 of these on space station currently, and they are named Bumble, which is blue, Honey, which is yellow, and Queen, which is green.
So cute.
So,
I love the
when we
bee
see
reference.
them, we see them on
Yeah.
camera. We always know which one it is
Of course.
based on the color.
Yeah.
So yeah, so this is my favorite robot. We just finished building these and launching them.
Yeah, they've-
very exciting.
Yeah. It's
And
been an exciting
full
year for the
disclosure
project.
here, it's Maria's favorite robot because the past 4 years
Of my life.
it's been spent working
Nothing
on
but
this
Astroby.
robot.
Yes, exactly.
Fair enough.
So when
That's
you
your job.
ask how long it takes to build something, well, Astroby, it's been now almost 5 years since we started, but
That's true.
but we finished building them and launching them within those 5 years. So
Okay.
so they're now starting to operate within those
Yeah.
5 years. So about like little over 4 years to build the actual flight units.
All right.
And so I can tell you a little bit about how these work. Usually
do.
the number one question I get when talking about Astrobys was, how do they move in zero G, right?
exactly.
Yeah.
So first of all, Astroby only works inside the space station because it needs air.
Ah.
It's fan-based propulsion. There are 2 fans on board. These sort of circular. Here, rotate
Yeah,
it
we can
again
turn it,
so
yeah.
you can see it better. There we go. The circular opening that you see on the side. Maybe scooch it that way a little. There we go. Steering here. Okay.
So the circular thing looks
The
like a
circular
speaker?
thing looks kind of like a speaker. There's an impeller fan in there, so that pulls air in and lightly pressurizes the propulsion module. And then those grills that you see, there's 2 on every side, so there's 12 total. That's right.
I've seen
Those
Abby's
are
hands
nozzles.
there.
There's
Yeah,
Abby's
that's
fingers
me.
coming in the
Right.
screen.
Should be like Maria's hand.
So those are the nozzles, and they open and close, releasing some of that pressurized air. And that's how it pushes itself around the space station.
All right.
So yeah, it's very light pressure. It's only about 0.1 psi over the ambient station pressure. So very safe. It's not going to blow up or anything.
The astronauts
Yeah.
don't feel a wind.
They will
when
feel.
they-
You'll
Oh,
feel the
do
breeze.
they?
In fact, we've seen it when it's operating on orbit. We'll see like hair moving,
really? Okay.
little flags fluttering. So yeah, you can
Neat.
definitely see the air is moving.
Yeah, I
but
see.
it's not going to like push them out of
Oh,
the way.
right,
They're a
right,
little too
right.
massive for this to push them
Gotcha.
around.
Yeah,
Yes.
cool. All right.
So, and then of course the other question we always get is how does it know where it is? How does it move and navigate?
and not crash into the walls and that sort of
Exactly.
thing.
Yeah. And
Or
the
bump
way it
into
does that
astronauts.
is this sort of central white section that you see right there.
Yeah.
is the heart and soul of it. It's the core module. Inside are 3 cell phone class computers. So pretty much the same as your cell phone. And it uses a camera. I don't know if
Well, actually,
see,
it uses a set of
there we
cameras.
go, a set of cameras. But the main camera, the navigation camera on this end right there, it uses that camera to look at features inside the space station.
Okay.
So it has a map that it keeps on board of features. It knows where those features should be in the station, and then as it's flying around, it compares what it currently sees to that map to
Right.
figure out where it is.
Say,
in the
okay.
station.
Yeah, so
Nice.
just like humans recognize landmarks to
Right,
understand
yeah.
where we are, this does that, but in a much more precise manner.
Yeah.
And I think the other thing that Maria was kind of pointing at is that we've added a whole bunch of cameras on here that's really enable it to fly around and know where it is. Some of these are optimized for really sort of like the close-in docking that you might want to do with a robot, where you need a lot of accuracy. and others are for just sort of like free flight, where you're really just trying to worry about, hey, am I going to be in the center of a module or near a wall, and that kind of thing.
Oh yeah, I see.
And then the last thing I like to point out on this model, and part of the main purpose of this robot is to carry payloads. We are actually going to be replacing the spheres that we saw earlier to